Welcome to 11th lecture. We are studying probability and statistics, and in this lecture we will study how to plot a dot plot and a relative frequency histogram using the software Minitab. We have been studying Minitab, and previously we learned drawing various other graphs like pie chart and bar chart using Minitab software. Today we will see how to draw a dot plot and a relative frequency histogram using the same software Minitab. So let's start with the dot plot. The data given is the one that we came across in our last lecture, maybe in 9th or 10th lecture. It is the same data. This is the data of CGPAs obtained by different students in a given class. But a clerk is going to enter this data and he or she makes a mistake here. Instead of writing 2.1, he or she writes it as 0.21. So there is a mistake. This decimal point should be here. So we will see that how a dot plot can be used to quickly pick this mistake. Right. We drew its dot plot in our last lecture and manually, and we studied that this 0.21 is very far away, from the rest of the data, and we called it outlier. This outlier is very far away from the rest of the data, and therefore we can easily doubt on it that it's not a valid data point. Right, let's go to Minitab and plot a dot plot for this data. For the convenience, I have already entered this data, the same data here: 2.8, 3.0, 3.0, 3.3, 2.4, 3.4, 3.0.21. The same data I have already plotted. I have already entered here a CGPA. So in order to plot a dot plot for this data, we'll go to the graphs tab and we'll click on dot plot. Right, and we'll select simple dot plot, and since there are two columns and we want to plot dot plot for the first column CGPA, we'll select CGPA. We'll press the select button and then OK. Right, so now it's a dot plot for this data, and we see that this point 0.21, which is mistakenly written as 0.21, actually this was 2.1, is very far away from the rest of the data. Therefore it is very easy to pick this point and can easily be declared as an outlier. Right? And if this mistake wouldn't been made, that would be 2.1. If the plot is like this, if the clerk would have not made this mistake, the data would be like this, 2.1. So this shows that it's not an outlier. Right, so this is how we can pick an outlier. Maybe if this was entered as 0.3 by mistake, so let's see what would it be then. It would again be an outlier. So this dot plot can be used to indicate an outlier. Right, so the other thing that we want to study in this lecture is relative frequency histogram. Relative frequency histogram, we studied relative frequency histogram in our last lecture, P&S11, but that wasn't using Minitab. We manually plotted this relative frequency histogram. Let's see how can we do that using Minitab. This is the same data we used in our last lecture. It's a birth weights data we studied in our last lecture, P&S11. This is the data set, the raw data set of birth weights of 30 kids, and we want to plot a relative frequency histogram for that. And let's go to Minitab and enter this data. Oh, I have already entered it for you. These are these 30 entries, 30 numbers I have already entered in this column, birth weights column. The first is 7.2, 8.0, 8.2, like this, 7.2, 8.0, 8.2, and second last is 7.8 and then 7.7. Let's see, 7.8 and then 7.7. 7.8 and 7.7, right? That's all. So I've already entered this data, and let's leave this plot, and now we are going to make a histogram, a simple histogram for this data, birth weights. Select this column and then press OK. Right, now this is the histogram plotted by Minitab for this data birth date. But let's see how many bins are there. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it has automatically selected 9 bins. We studied in the last lecture that depending on the size of the data, we can select any number of bins between 5 and 12. So Minitab has automatically selected 9 bins for it. But in our last lecture, we plotted this frequency histogram using 8 bins. So let's see how can we do that using Minitab. We'll go to edit graph and we'll select X scale and then the edit properties, and then we'll go to binning. So here we have automatically interval definition is automatic by default, but you can change it to number of intervals and you can make it 8. Because in our lecture we selected 8 bins for it. Okay, right. So now this graph is very much like we studied in last lecture, but not exactly the same that we studied in P&S10 lecture. Why? Because the bin definitions are not exactly the same. The bin limits are not exactly the same. Here we have bin limit maybe 5.2 to 5.8. 5.4 is the center. But if you remember in our last case, we selected bin limits. We started from 5.6. And the interval we selected was 0.5. But the difference is that here the Minitab is using the same number of pins, but it is starting from 5.2. We started from 5.6. So this is the difference. And there is one other difference, that we selected pin widths to be 0.5, but here it is taking it to be 0.6. So how to handle this and make it look like exactly what we did in our last lecture? We can do that by selecting midpoint or cut points, right? So we have to mention all cut points or midpoints here. If we started from 5.6 and then we went 0.5 higher, so the bin definition was 5.6 5.6 P&S10. So let's see what we did in our last lecture, P&S10. Right, this is the last lecture. And what are the limits we selected? No, that was P&S9. That was P&S9, right? So in this lecture, we studied these upper limits. 5.6 was the lower limit for bin number 1 and 6.1 was the upper limit. So what should be the center? 5.6 plus 6.1 divided by 2. That would be 5.85. 5.85 is the center for the first bin. Similarly, 6.1 to 6.6. So 6.35 would be the center of this. Similarly, 6.85 would be the center of this bin. So we can mention centers here. So this first center is 5.85 in our case. The next is 6.35. The next is 6.85. The next is 7.35, 7.85, 8.35, 8.85, and 9.35. How many are they? 1, 2, 3, 4, 5, 6, 7, 8. Now we have 8 bins and we have mentioned all the midpoints. 5.85, 6.35, 6.85, 7.35. All right. So now it looks exactly the same as as it was it was drawn in our last lecture in P&S11. Let's see. Right, here we are. 2 2 4 5 8 5 3 1. So now it looks exactly the same. But this is histogram. We have frequency here versus birth rates. It's not relative frequency. To make it relative frequency, we have to make some manual modifications. We have to select Y scale from here, and then we go to scale show type attributes labels, right? Labels. So labels, we have to specify labels here, but the labels right now are 0 1 2 3 4 5 6. So but we want them to be relative, and since we have 30 instances or 30 data points, so we have to divide every height of every bin by 30. So this should be 1 over 30, 2 over 30, 3 over 30, 4 over 30, 5 over 30, 6 over 30, 7 over 30, 8 over 30, and finally 9 over 30. Right, so if we do this, right, now we have this scale as relative frequency scale. Instead of frequency, this is relative frequency now. But we can do that, but one other thing is that this label should also be relative frequency. Axis label should also be relative frequency. So now we are done. Now we have relative frequency label, and the scale is also relative by dividing each number by 30, and on x-axis we have the same bin definition, same bin centers, and same bin widths for all bins that we used in PS9 lecture. So this is how we can draw frequency histogram and relative frequency histograms for a given data. That's all for this lecture, and with this lecture we have concluded chapter number 1, and from the next lecture onwards, P&S12 and onwards, we will study chapter number 2. Thank you.